Okay, so our final unit is on sequences and series. And we'll be looking at two different types of sequences and two different types of series. So down here, I have a couple of sequences for us to look at for fun and to see what's happening, say, in this first one, 2, 4, 6, 8. Well, you can see that the next numbers in this sequence would be 10, 12, etc. I'm adding 2 every time. So a sequence, by definition, is a list of objects. So in this case, it's a list, and I separate each element, each term, with a comma, and it follows a rule which allows you to determine the next term. So if I look at this first list, what's the rule that would define it? And I would say, well, my first term is 2. That's term 1. And then to get the next one, I take that 2 and I add 2 to it. And then the next one, I take the first term and I add 2 twice. And then the next one after that, would be 2, and I add that 2 a third time. So this is 2, 4, 4 plus 2 is 6, 6 plus 2 is 8, and so on. So the way that I would write that out would be 2 plus 2 times n minus 1, where n is the position of the term. So if I look back at this one, term 1 is 2, term number, and then down here the actual term. So we could even call this like the position number up there. Whoops, that made a mess of that. So let's go back here. Position 1, position 2, position 3, position 4. Term 1 would be 2 plus 2 times 1 minus 1, which would be 0, and I would be left with just 2. And then in position 2, 2 minus 1 would be 1, 2 plus 2 would give me 4, and so on. So this is how I would write out what we call a general term. So let's look at some examples to kind of see more of that. So our definition that we're working with today, this lesson, is on arithmetic sequences, and it's a sequence that has a constant difference. So in this one, I can see that the constant difference is the second term minus the first term. For example, would be 5 minus 2, which would be 3. Or I could take two other consecutive terms, like 3 and 2, and subtract those. 8 minus 5 is also 3. Or term 4 minus term 3 is 11 minus 8, which is also 3. And so you can see that it's constant. So now I know the constant difference, which we use the letter D for, in this case, is 3. And so I'm going to use this rule down here, which we call the general term for an arithmetic, sequence. So the nth term, the term in position n, so that's what it means. Right here, Tn is term in the nth spot. So first, second, third spot, or whatever, is term 1, which I can see is 2, plus n minus 1, that part doesn't change, times d, which is 3. Okay, so we're going to use that to find term 6 and term 20 and term 1000, these exercises up here. So term 6 is going to be term 1, which is 2, plus n minus 1 times 3. So that's going to be 2 plus 5 times 3 is 15, so plus 2 is 17. And term 20, 2 plus 20 minus 1 times 3, that gives me 59. And down here, 2 plus 1,000 minus 1 times 3 turns out to be 2,999. So in this unit, hopefully you're making a few notes here. You want to write down this formula. This is going to be really, really important for what we're doing. The general term for, and I want to specify an arithmetic sequence. Okay, let's see some more examples of how to use this formula. So here we have a couple of examples. Given the sequence 6, 9, 12, 15, determine first the common difference. The general term is that formula we saw earlier, term 10, and then which term is 51. So I'm just going to put up my formula here again so I don't forget, but the nth term is term 1 plus n minus 1 times d. So that's my equation that I'm working with in these problems. So the common difference is take any two terms and subtract them. This one, term 4, minus the one in front of it, which is 3. So 15 minus 12 is 3, just like 12 minus 9 is 3, just like 9 minus 6 is 3. So I know that part is 3. The general term means put that into this equation. So the general term of this sequence is term 1, which is 6. That's right here. Term 1 means the first one, plus n minus 1 times d. And there it is. And now the 10th term would be 6 plus 10 minus 1, which is 9, times 3 would be 27 plus 6 is 33. And now I'm doing a little bit of a problem here. Which one is 51? So in my formula, 51 would go here. It would be the nth term. That is term 1 plus n minus 1 times d. And I want to figure out what's n. So which term is 51 is really asking what's n for that case. So I'm going to subtract 6 from each side. And that is going to give me 45, and that is 3 times n minus 1. Then I'm going to divide by 3, and that's 15. And I'm going to add 1, so 16 is n. So this is the 16th term. So I could say the 16th term is 51, without having to write out all of the terms until I find, oh, the 16th one was 51. I can use these formulas. Okay, let's go and clean up some space here and try some of these other problems. So in the next one, we're given part of the sequence, but you can see the first term's missing, so is the third term, and so is this last term in what we're seeing for this sequence. So luckily, I have these two adjacent terms. And what I'm going to do is go 28 minus 36, and that's going to give me the constant difference. And in this case, it actually turns out to be negative. It's negative 8. So every time, as I go along in my sequence, I'm decreasing by 8. So this must have been, this must have been 60. Less 8 is 52. And if I take away 8 from that, I'm going to get 44. Minus 8 is 36. Perfect. That works out. And then down here, I'm going to get 20. So the general term is Tn is the first term plus n minus 1 times the common difference d. So the general term is 60 plus n minus 1 times negative 8. And of course here I could do the algebra and go minus 8n plus 8, 60, and so on. And then just say, well, that's negative 8n plus 68. And I could write it that way. But this is sufficient as well. You might see in some homework or assignments this is the answer looking like that, though, but know that those mean the same thing. Okay, and now here, how many terms are there in this sequence? So if this is my last term, I want to know how many are in here. So first thing I'm going to do is take two terms and subtract them. So term 3 minus term 2, 25 minus 11 is 14. Now I know the common difference is 14. I can set up my equation. The general term is negative 3, which is term 1, plus n minus 1 times 14. And so how many terms are there in the sequence is really asking, this is term 1, this is term 2, this is term 3, this is term n. What is n? So similar to that other problem we did, I'm going to put the 823 here. And I'm going to add 3. So I'm going to get 826 is 14 times n minus 1. And now I'm going to take 826 in my calculator, divide by 14, and I got 59. And add 1. So n is 60. So that's kind of a little bit different style of problem versus just applying, our formula and so on. But that's kind of how these guys work. Lastly, this challenge one, you might want to give that a try. You could pause the video here and try this. See if you can find the common difference and so on. And now, let's see. So term 1 is 3x plus 2. The common difference is this term, 5x, minus the term before it, which would be 2x minus 2. And another way I could do that would be using these two terms here. So I could say 8x minus 6, take away the term that come before it, 5x, and that's also the common difference. So 3x minus 6 is also the common difference. So now what I'm going to do is a little bit of a system of equations that we saw in the other unit. I'm going to make this, right, equal to that, because they're both equal to my variable d. So 3x minus 6 is 2x minus 2. I'm going to take away 2x. X minus 6 is negative 2. So x is 4. And now I can go back here and put these in. So 3 times 4 is 12 plus 2 is 14. 5 times 4 is 20. And 8x minus 6 would be 32 minus 6, which would be 26. And you can see each time I go up by 6. So if x is 4, the common difference is 6. And there we have it. There are our first three terms of this sort of hidden sequence using the variable x.